Okay, just a few slightly harder ones, which tend to sometimes be merit and things like this. This one's probably not merit, this one's probably still achieved because it's still relatively easy really. Got the equation, we will need to find fx, which has the derivative of that, for which fx cuts the y-axis at 2. So in this case we're thinking about, we've got y-axis fx, so that means if this is the y-axis, y equals fx. Okay, anyway, so that's what it's meaning. Fx is just y. Okay, if it cuts the y-axis at 2, this is the y-axis, cuts the y-axis at 2, so that means it goes through that point there, which is x is equal to 0 at that point, and y is 2. So that's what we're going to use to figure out c, etc. Okay, so now we've done our anti-differentiation, our integration, and we've got fx now. We should be able to get that pretty easily by now. We always double check. If we differentiate that, 3 times 3 is 9, that goes to x squared, cool. 2 times minus 2 is minus 4, yep, and c differentiates to 0. That's why we always have the plus c there. So now we can use this information to figure out c. So we know this point here. So when x is equal to 0, so if that's 0 and that's 0, 0 cubed is 0. Of course, 3 times 0 is 0, and minus 2 times 0 is 0. I'm just writing that there really quickly just to show you that when x is 0, this is really simple. So when x is 0, y is equal to 2, which means fx equals to 2. So that's pretty simple. That just means c is equal to 2, right? And if you haven't quite figured out what's going on, that's 0, that's 0. So all we're left with is c equals to 2. Okay? So there we go. We've got our final answer there. Cool. Always got to write the whole thing again with c there. Okay? And so now if we plotted that, that's Alt Tab doesn't work when I'm doing this, it would seem. Anyway, if we draw what it looks like, we can see that's what it looks like there. And of course, it goes through the y-axis at 2, which was exactly what we predicted. So it looks something like that, or whatever it just looked like. That's cool. Alright, here's another type of question that this one might be a merit question because you have to use another skill at the same time as anti-differentiation, and it's a little bit harder. The key is realizing that this, before we can integrate that, anti-differentiate, we have to use this rule here. Remember, when we have something over something to the power, that's the same as that to the power of the negative version of it. So therefore, minus 9 over x to the power of 4 is equal to minus 9 times x to the power of negative 4. Okay? So we've rewritten this like that, and now we can anti-differentiate. So 6, of course, goes to negative 6. Now, this is going to be tricky here because we've got a negative number. What are we gonna do here? Let's just write it over here. Negative 9x to the power of negative 4. Negative 4. Sorry. If we add 1 to negative 4, that becomes negative 3, and divide it by negative 3. So in this case, using the formula makes it a bit easier. And so then, of course, negative 9 divided by negative 3 equals positive 3. So let's think about that. If we differentiate that, what's going to happen? Negative 3 times 3 is negative 9, and negative 3 minus 1 is that. So that's correct. Okay, so writing that down should look like that. Okay, so we always go and just double check. Negative 3 times 3 is negative 9. Negative 3 minus 1. Yeah, we've definitely done all of that right. And 6x goes to 6. Don't forget the plus c. Fantastic. Okay, and this is where we go. We're trying to find the particular solution given that they pass through the specified coordinate. Here's our coordinate over here. X is 1, y is 14, right? Now, again, we keep ourselves simple. We're going to put this side over on the left. And I'm not even going to write down 6 times 1. Yeah? 6 times 1 is 6, isn't it? Okay. And then I'm going to do here 1 to the power of negative 3. If you put that in your calculator, you'll see that, of course, it's just 1. Because 1 to the power of negative 3 is the same as 1 over 1 to the power of 3, which is just 1. Anyway, cool. So that's also 3 times 1. So that's just 3 plus c equals, remember I got this the other way around, equals y. So it equals 14. So now that's pretty easy. C equals 14 minus 9, because 6 plus 3 is 9, which is 5. And so now you can see there is my final answer. Remember, we can't just calculate C and be finished. We have to rewrite the whole equation with the plus C in there. So the key thing that made this a little bit harder was we had to use this simple algebraic idea, which we know about from algebra. Now, if you really wanted to, you can leave it like that. That's absolutely fine. But if you really wanted to be super awesome, you could change this to 3 over x cubed as well, if you wanted to. Okay, that's again using this thing. Okay, but you don't need to. Cool. So there's our final answer there. And of course, if we put this equation into Desmos, we would see that it would go through this point. But I'm not going to bother doing that for this one. Okay, now this question, I'm not sure if this particular one would be an excellence question because it's not too hard, but I don't know. I'm always surprised at what's excellence in year 12. So let's say it's possibly, but don't quote me on it. But let's not worry about that right now. This one is much harder because it's a second order differential equation. You'll see it's got f dash dash x. And instead of just being given one piece of information here, we're also given a value of f dash. Okay, there. So f dash dash x means, well, what's going on there? That's something that we haven't really talked about yet. So before we continue with this, I'm just going to talk about what a second order differential equation is. Okay, basically, long story short, the second order differential is just basically where we have differentiated twice. So all we need to do is find the first order. What that means is f dash, second order f dash dash. It just means we've differentiated twice. Okay, so we find the first derivative, f dash x, which is 3 times 4, 12x squared, and 2 times minus 2 is that, and 4x goes to 4, and of course minus 5 differentiates to 0. So we found that. So this, remember, gives me the gradient of this at any point. And now, if we've got this, we can find how the gradient changes for that one. So which is just finding the derivative of that. Okay, so that's pretty easy. 2 times 12 is that. Minus 4x goes to minus 4. And of course 4 goes to 0. So this is the gradient of this one at any point. Now, the second derivative also tells us a few other things, but we're not going to worry about that right now. But that's it. Basically all it means is, okay, we've differentiated once, then twice to get that. So what that means is we know this, we're going to need to anti-differentiate once, then twice. So the first time we do it, we've got a plus c, we need to figure that out. Then we're going to integrate again. We've got another plus c that we're going to figure out. So let's just look at this question and figure out what we're going to do. Now we have the second derivative. So the first thing we can do is anti-differentiate to find the first one. Now that's 12x to the power of 1, so x squared. Then I think about what's happening if I differentiate that 2 times 6 makes 12, right? And 2 comes just from 2x. It's a bit of a funny looking thing there. Anyway, and then there's a plus c. Always just double check. 2 times 6 is 12. Yep, we've definitely done that, right? And so now we go, so what information can we use to find c? Right here, we see f dash 0 equals 1. Remember, this is x, isn't it? X. So that means when x is 0, f dash x equals 1. So we can use this information to help us find c. So we're going to substitute it in. This is pretty simple. Again, I'm not really going to write all of this down because if x equals 0, 6 times 0 squared is just 0. And if x is 0, 2 times 0 is 0. Basic plus c, and it equals 1. So f dash x equals 1. So therefore, c equals, actually I'm going to write that to the side just so I've got a bit more space. C equals 1 for this first part here. So now, if I rewrite f dash x, looks like that. Easy. And now I'm just going to anti-differentiate or integrate again. So now I've got f dash x. So now I can see what fx equals now. Adding 1 to there. And then I think about 3 times 2 makes 6. So that's going to be there. And x squared, 2 comes to the front, there's a 2 there, so we just leave it like that. And of course 1 times x is just x plus c. You'll note that I've used c here and I've used c here. That's fine because I'm figuring out this c. Now I'm doing another equation where I'm finding c again. They're different c's. If that confuses you, you could use c and d or c1 and c2, but that's fine. Now we can see we've got the other information, f0. So that's just here, that's fx. So again, when x is 0, f of x equals 2. So I'll write that there. Equals 2. And again, this is really simple. I'm going to write it down again. So 2 times 0 cubed, that's just 0. 0 squared is 0. 0 is 0. I don't need to write that down, but I'm just doing it to make it really clear. And so when x is 0, fx equals 2. So therefore c equals 2. There we go. Okay, and so now we have our final answer. Remembering again, we know what fx is and we know what 2 is. So we'd have to then just write down that final answer. Cool. And so we can see how this is going to work again, because this is going to differentiate to this, which is going to differentiate to this, and these work for all of those situations anyway. So that's how we do it if we have a second order one, if it's f dash dash x, or if it was y, it would be y dash dash. Okay, that's not too hard to see. If it was a second one, we have y dash dash. Sorry, you can't see that. Y dash dash, it's the same idea. Okay, so more sort of harder questions like this, as I told you guys yesterday, is 58 to 59 in your Walker Maths book. For more of a challenge, try see if you can do these ones. They, like I've just written, they use the same kind of skills that we've just learned, but in real life context, which makes it a little bit trickier, but it's the same kind of ideas. Otherwise, I can see it's blocked out there, but what I've written in purple is the easier, more achieved ones. Just work through those pages 56 to 57 if you found those other kind of questions a little bit hard at this stage. Alright, cheers. Have a nice day. Go outside.